Welcome guys, grade 12. This is a lesson for you in mathematics. We are doing the continuation of Euclidean geometry, guys. So this is particularly Euclidean geometry that involves the grade 12s. As you can see on the bottom written, similarity in polygons. We are going to have to be familiar with the concept of similarity. Generally, guys, when you are saying so and so is similar to another person, you are saying they look alike or they are having features that make them to be more or less the same. So that is what is meant by similarity. So polygons, we learned that they are shapes having many sides. Poly means many, so we are going to be learning similarity in polygons. So many starts from 2, guys, but I don't know any shape with 2 sides. It starts from a triangle, a square, to the hexagon, and so on and so forth. So we are going to be having polygons that are similar. What are similar polygons, guys? Let me draw maybe this polygon. I don't know what I'm going to call it. So we are having that polygon A, B, C, D, E, F, G, H, I, K. So if we are having angle A there, guys, equal to angle F, having angle C equal to what is that? Is that also C? It's E. It's A, B, C, D, E, F, G. This was G. So I'm having C there equal to H. I'm having that side equal to that side. I'm having this side equal to this side. So I'm having all the angles in these 2 different polygons, guys. I think you can see clearly that they are different, but we are having angles there. Angle A being equal to angle F, angle B being equal to this G. I'm not going to write them all, guys. But it comes in this way, guys, that those polygons are concluded to be similar, guys. They are similar if they are having corresponding angles equal. So this angle corresponds to this one, and so on. This angle corresponds to this one. So if you are having 2 polygons having corresponding angles that are equal, it could be in numbers. If it's 30, it will be 30 there. So that is the concept of similarity in polygons, guys. But we are only interested, according to the CAPS curriculum, we are only interested, guys, in the similarity that comes with triangles, guys. We are going to be dealing with triangles. So if I'm having similar triangles, I'm going to be having also 2 triangles, guys, that do not have to be equal, but if they have corresponding angles that are equal, they will be concluded similar. Say for instance, in this case, I'm having angle A being equal to angle D, I'm having B equal to angle E, I'm having that side, so that angle C being equal to angle F. So I've actually got 3 angles here, angle A being equal to angle D, angle B being equal to angle E, and angle F being equal to, sorry, it's angle C being equal to angle F. So if I'm having all these 3 triangles and both triangles corresponding, guys, I could conclude that triangle A, B, C is similar. This is the symbol we are going to be using for similar, just 3 lines, guys, that are not laying horizontal. Remember, this is congruent and this is similar. So we are saying triangle ABC is similar to triangle DEF. if you can see the manner I've written them, I've got angle A being equal to angle D, so I've written A which corresponds with that D. I've got angle B, guys, being equal to angle E. I've got B the second and E the second. So it must correspond the way in which you write in which you name your triangle matters, guys. So I've got angle C there being equal to angle F. I've got C at the third position and F in the last position. So I've made those angles to correspond in the way I've named my triangles. There is also a special feature, guys, about triangles which does not apply to other polygons but only triangles. So we can conclude that triangles are similar if you've got three angles equal. Remember, guys, this is still Euclidean geometry. If I've made a statement that says triangle ABC is similar to triangle DEF, what should be my reason? I've got three angles, guys, that are equal. Some people write it like this way. So I've got three angles being equal. So I've concluded that my triangles are similar. This is the reason. Okay, so coming to that special feature that the triangles have that is different to other polygons. You can prove in two ways, guys, how a triangle is similar to another. Firstly, if you can find three angles that are equal and corresponding between the two angles, the two triangles, you can conclude that those triangles are similar, guys. So coming to the second way, you see if in this way, if I'm having triangle, let me name it J, K, or let me come right here at the top. I'm just going to erase this, but we need to take note of what I've just erased there. Say for instance, I'm having angle J here, K, L, and triangle. So KLM, let's say P and Q there. If I'm having the length of JK being maybe 2, and this side being 3, and this side being 1, should I make it 1? No, let me not make it 1, but let me make it, let me make it 10. So that this side I'm having 4 and 6, and maybe 5. Or let me make it 20, guys. So if I'm going to take this side, the length of the side JK, and divide it maybe by MP, guys. Remember, these are the magnitudes or the size of the length of JK. JK, I said it must be 2, and divided with MP, which is 4. 2 divided by 4 is half, guys. Say for instance, I take JK and divide it with MQ. So I've also got 3 for JK and 6 for MP, which gives me another half. So lastly, I'm going to take KL and divide it by PQ. It should be 10 over 20, which will also give me a half. So I just want to come to enlighten you guys on the second feature, which we say we can prove that certain triangles are similar. If I can find that, guys, the ratio of the corresponding sides, remember the ratio, that is why I've divided JK by JK. It is a ratio. So if I say a ratio of corresponding side, I'm saying if you divide JK by MP and it gives you half, and you find other two sides that when you divide the other with the other also gives you half, like in this case, JK, this was supposed to be JL, sorry, like JL over MP, and it also gave me half, and the KL and the PQ also gave me half. So if I'm having the ratio of the corresponding sides on two triangles, guys, that are equal, I can also conclude that triangle J, K, L is similar to triangle NPQ, triangle NPQ. So what would be my reason, guys? Remember I said the ratio of corresponding sides, guys, is equal. Or you can simply say the sides are in the same proportion. It is a more similar way of saying that the ratio of the corresponding sides are equal. So if you can find that in any case, when you find two triangles and you divide certain sides and they give you the same ratio, you can conclude that those two triangles are similar. So this will add to the definition. We are having another theorem, guys, which says similar triangles have the corresponding sides equal. In fact, it is the converse of this theorem, because we've just said if you are having two triangles that are in the same proportion, or that are having sides that are corresponding and give you the same ratio, you can conclude that those triangles are similar. So we are saying the converse of that. If you can find that two triangles are similar, you can conclude that the ratio of the corresponding sides are in the same proportion. So what do I mean by this? I'm just going to make some space here and remove this polygon. If for instance I'm having a triangle ABC, guys, and triangle DEF, and these triangles, guys, will be included in your circular geometry. Remember, you learn how to find certain angles using the theorems from grade 11. So they are going to be somewhere within the circle because they are combined with circular geometry. And you can prove that angle A is equal to angle D, or at least we are given an angle B is equal to angle E, and angle C is equal to angle F. You can conclude that triangle ABC is similar to triangle DEF. Remember, we said if you can find that two triangles are similar using their angles, your result will be angle, and you found that those three sides in two triangles are equal. You are further extending this, saying that similar triangles are in the same proportion. So by saying this, that similar triangles are in the same proportion, we are having triangle ABC there similar to DEF. So we can further say that from these similar triangles, I know that AB divided by this DE. Remember, I've taken the first two. I highlighted earlier that it is very important, guys, the order in which you put or the order in which you name your triangle. I'm having AB to mean that this angle A should always be equal to D. That B should equate to E. That C should equate to F. That is the manner in which you are supposed to write or to name your triangle. So I'm having AB there divided by DE, which should be equal to, I'm taking the second and the last, it's BC, which I should divide by the second and the last from that side, which is EF, which is also equal when I take the first and the last, which is AC on that side, and I take the first and the last. Remember, you're having three sides in a triangle, which is DF this time. So you can conclude this when you're having two similar triangles, guys. We are going to be given questions where we will have to use to calculate actually using those ratios. But the way you take them, you can only take two when you calculate, guys. So say for instance, I'm having triangle ABC, I'm having AB being 2 there, I'm having EF being 6, and I'm having, let's say BC being 3. and maybe they say calculate the length of DE, guys. They say calculate the length of DE. You've just been told to prove that certain triangles are similar, and you've actually proved that. If you guys cannot prove it, do not get worried. If the question is out of 3 marks, guys, the last mark will always be on the reason of the conclusion. So if you fail to prove that certain triangles are similar, but you must always go to a length, guys, to grab that 1 mark. Just write that the certain triangle that I'm required to prove is similar to that triangle. So for instance, if the question says prove that triangle ABC is similar to DEF, and you could actually not prove by being unable to calculate the sides of the angle and prove them that are equal. So what you should do is go to the last line or to the first line if you are not going to answer it at all. Go to write a statement that says triangle ABC is similar to triangle DEF, and write this reason this way. Write a triple A, you will always get a mark, guys. Trust me on that one. It will always be the case that it will always be 3 angles that are equal. So do not forget this part. If they say prove a certain triangle is similar to another and you could not prove it, always write this final statement and you will get a mark for that. I hope you got that. So I said in this question, maybe they say calculate the length of let's say DE. So you could see a pair that involves what you have. You are having AB, you are having BC, you are having EF, and you are required to calculate DE. So you have to pick a pair, guys, that includes what you have and what you want. So you are having AB, I'm having AB there. I'm having EF. EF is 6, so I'm having EF there. So when I picked the two, you could tell that for this one you should use this AB over DE is equal to BC over EF, guys. So I'm having AB as 2. What is my DE? My DE is what I'm being asked for. DE is equal to what is my BC? It is 3 units there divided by what is my EF? My EF is 6. So you could say that you can solve for DE using your mathematical skills, guys. I just want to show you how to apply this. So that is it for similar polygons, similarity in polygons. I want us to look at another thing that includes grade 12 frequency geometry, the proportionality theorem, guys. I'm sure most of you have done this topic, but I'm just going to go through over it because it is also going to help you. Proportionality theorem, guys. Remember, I said in caps grade 12, you see here, we are dealing with triangles, but not any other polygons. So if I'm having triangle A, B, C, D, and maybe let's say E there, and we are having BE being parallel to CD. Let's first talk about what you will need to know about parallel lines, guys, in grade 12. In grade 12, we have to know that triangles that lie between the same parallel lines have the same area. Remember, the formula to calculate the area of a triangle is half a base of the triangle multiplied by the perpendicular height of the triangle. So this proportionality theorem actually includes the area of a triangle. So it's calculated by that equation, guys. The area is half base times height. So this Things you need to know about parallel lines, guys. I'm having A, B, C, and let's say maybe D there. If I'm having BD being parallel to AC, if I were to calculate, guys, the area of triangle ABC here, let's see area of triangle ABC. I'll have to say it's my half base. Which one is my base? It's AC there. It's my half AC. And which one, guys, is my perpendicular height? If you could look at triangle ABC, I'm not having anything perpendicular, but having anything perpendicular there. So the only perpendicular height or the perpendicular line that is besides the triangle ABC is that CD. Is that CD, guys? So I'll have to write this 3D. And also if I were to calculate the area of triangle BDC. So you'd see that actually the area of triangle would be the half of BD multiplied by which one is the perpendicular height there of triangle BDC. I think you could all agree with me that it is DC. So if you are guys to calculate and come out with the final answer, you'd have the same area there of those triangles. So this thing we are going to need to learn about parallel lines in grade 12 is that triangles between the same parallel lines have the same area, guys. So that is all we are going to have to learn, is that the area of triangle ABC is the same as area of triangle BDC. Why, guys? We are saying there are triangles between same parallel lines. Same parallel lines, and they should be having the same base, guys. They should be having the same base. So that is all we are going to have to learn about parallel lines in grade 12. There's nothing much, but if you did not hear what I was talking about here, do not worry, we are going to come to it when we are actually doing the proof of the proportionality theorem. It's only a small part. If you cannot understand this one, that the area of triangles between the same parallel lines are equal, you are going to write that as a reason in one of the steps of the proof of the proportionality theorem. So what does this actually proportionality theorem talk about, guys? So it goes like this. The proportionality theorem states that the line that a line that is parallel to the third side of a triangle divides the other two sides of the triangle proportionally. I'm going to say that again. A line that is parallel to the third side of a triangle divides the other two sides of the triangle proportionally. So which line, according to our diagram, is parallel to the third side? Remember, we're talking about triangle ACB. We are having BE being parallel. I'm not sure if this color is going to be visible. I think I've ran out of white chalks here. BE being parallel to CD. So this theorem goes further to say that it divides the the AC, that is, it divides at B and it divides the AD at E. So it means that these two sides, the AC and the AD, are divided proportionally. The AC is divided to AB and BC, and the AD is divided to be AE and ED. So what does it mean when we are saying that this third side, which is BE, divides the AC and the AD proportionally? So to divide proportionally is to divide in the same ratio. So we are saying that when you're having AB being divided by the BC, it should give you the AE divided by the ED, guys. This is what the proportionality theorem states. So if you can see how I've written I've written first the AB and divided it by this side. Again, I wrote this B, C at the denominator there, and then I wrote at the denominator on that side the ED. So if you can say I've said AB, this AB divided by this BC on the left hand side. On the right hand side, I said it was AE divided by this ED. So you have to be careful about how you pick out the sides that you are saying they correspond. So there is no actually order, guys, on how you pick those sides, but you have to make sure that they actually correspond. So how would they correspond if you were to pick maybe AC on the left hand side? Let's say AC there. You'd have to, guys, to obviously pick AC on that side on the numerator. Now I've picked the AC. If I want to pick BC on this side, I'm dividing by BC. So BC corresponds with ED divided by ED there, guys. So it's actually going to be an easy topic, this one, because you can say you are having a lot of choice. Or from what you've written there, guys, I'm having AB divided by BC, having AE divided by ED. If I can take the numerators, that is AB, and divide by the numerator on that side, AE, it should be equal to, when you take the denominator BC divided by that denominator ED, guys. However you like it, you can even cross multiply that AE multiplied by BC and having AB multiplied by ED. You can do anything you like, guys, depending on the side you are having. So how are you going to apply this proportionality theorem? Okay, I forgot the actual reason. So we said we can conclude this from this theorem. The reason of writing this statement or these all ratios will have to be that it is the proportionality theorem, because we said any reason always state the theorem itself, proportionality theorem, guys. And you also have to state which lines are parallel. So we are saying it is the proportionality theorem, which lines are parallel. BE is parallel to CD, because this theorem has that part that says the third side that is parallel to the third side, guys. Okay, now let's see how to apply this theorem, guys, in our calculations. So in any triangle, guys, where you can by any chance identify a line that is at the center, I don't want to say at the center, but a line that is parallel to the third side of a triangle, we are going to use a proportionality theorem to solve some problems, guys. Say for instance, I'm having a triangle A, B, C, having that side made of let me say JK this time, and I'm told that JK is actually parallel to BC. I'm having that side to be 2, that side to be 5, maybe that side X, maybe that one being 6, and they tell me to solve for X, or rather calculate the magnitude the size of length AJ. So according to the proportionality theorem, if I'm having JK being parallel to BC, I can automatically use the proportionality theorem. So I know that if I'm having AJ divided by JB, that is on this side AB, what I did on the left must correspond with what I did on the right. I've taken AJ, I think this side I should take AK and divide it. I've divided by JB, so I'm going to divide by KC. So what is the reason for the use of this theorem, guys? Is proportionality theorem. You are always going to get a mark for writing that and a mark for writing this reason. Proportionality theorem, guys. Why proportionality theorem? Remember, we have to also state a pair of parallel lines. So AK is parallel to BC. You are going to get a mark for that. Now let's substitute the values. I've said that AJ equals to X units, JB is 6, and AK is 2, and then KC is 5. So we will know how to solve for X, guys. So we have to multiply with the 6 on both sides so that you could get a clear answer. 2 times 12, sorry, 2 times 6 is 12, and 12 divided by 5. I actually cannot estimate that, so I'm just going to write 12 over 5 units. But you always have to write your length on a decimal number, guys, because it should not be in a fraction form. So guys, at times you may be required to calculate the magnitude of the angle and magnitude of that angle at times to prove that the triangles are having a certain line which is parallel. So you can use the proportionality theorem. I will do no further examples on this. I'm just going to try to move to the proof of the proportionality theorem. Keep going. Should we do proof? I'm not sure if you can do it, but it's very easy, guys. You can look at it on your textbooks. On your textbooks, guys. It is there. It does not change. It comes out. It's a pity I'm not having any examples, but I want to come to one special thing you will find maybe hard at times in this topic. So say for instance we are having a triangle. I'm not sure if how am I going to draw this triangle. I think I've made it complicated, guys, but I think I'm just going to talk what I wanted to actually show you. I don't seem to have a clear example, but your triangles, as I've stated before, are going to be in your circle because we are doing circle geometry. So you will always have to prove at some point that certain triangles are similar. Now there will be a case where this case of having similar triangles, remember we said similar triangles are in the same proportion. So if they are in the same proportion, if you are having a triangle ABC being similar to triangle BCD, remember we said we could conclude that your AB divided by your BC should equate to your AC divided by your BD, which should also be equal to your BC divided by CD. I think I'm having a lot of BC's there. We said it's AB, C, B, C, D. No, I shouldn't. Okay, but let's leave it that way. But you could also find out, guys, that at other times we are going to be having the same triangle being involved in that proportionality theorem case. It could be A, B, C, C, D, E. Let's say this diagram was somehow connected to this triangle ABC, and that triangle ABC is that one. Or rather, let's put the B there, the C, and maybe E and J. But let's say you're having an expression from that proportionality theorem thing, from that proportionality that says AB over BC. Equates to maybe CD over maybe let's say AC. So you are having two expressions. This expression is from when you proved that triangle ABC was similar to another triangle. So you got this expression. Remember the reason for this is that the triangles are similar. You can simply write similar triangles. So after you concluded that those triangles are similar, when you are writing this ratio, your reason there should be similar triangles only, guys, nothing much. So let's say you are having this triangle ABC in that theorem of proportionality because they may come both at the same time. If they ask you similarity on one side and proportionality theorem on another question, you'll be very lucky. At times they may be combined. So maybe I wanted you guys to be able to use both at the same time. So it can always be that maybe let's say in this we are asked to calculate AB, you are having BC, you are having let's say it's JK, then you are having JK, you are not having AC, but from that equation, that second equation you found out using the proportionality theorem can help you find the value of that JK if you are having JK somewhere there. It may not be similarly that you will come out with the value of JK, but at times it may lead you to a more simpler way of solving. This is it, guys, for this video. We are going to record another one trying to answer the actual questions, combining now the grade 11 and the grade 12 Euclidean geometry. Thank you, guys.